Grammons. I'm from Lab 651, where we help our customers build devices and manage data in the area of the Internet of Things. And today we're going to be talking about part two of a series that I've been doing on deep learning. If you haven't caught part one, we went through how we generated a model to do a prediction based on an input of a Celsius value, and it would predict the closest Fahrenheit value. And it was all using deep learning and machine learning. There's a accompanying blog post with this video that we'll include in the liner notes that you're looking at right now here about TensorFlow serving. And also, if you have not caught part one, I highly suggest you'll want to go back and do that. So we have a link here to part one of the blog post, and that will walk you through all the steps which we will use later on in this to actually run our model using TensorFlow serving. So today, specifically, we'll be talking about TensorFlow serving, which is really, really cool. As I talk about in this blog post here, it's really cool that you can build a model using TensorFlow, using something like Colab, Jupyter Notebooks, all that type of stuff. But what I was always sort of, I guess, kind of scratching my head a little bit at is once I got done with these models being built, the power of the internet is really around APIs and being able to serve these models up to anybody that would want to. So it could be a microservice that you have built already. It could be serving up to some other third party or something like that. And so I was always kind of wondering, well, what's the best way to do that? And how does TensorFlow fit into this? Well, voila, the TensorFlow serving project was born, and it's been out for a number of years right now. And it allows you to take a model, and basically start up a server and utilize a model that you have already built and serve it up via REST API. So now you can leverage all of that work that you've done into building your models to creating a service that your applications, your web applications, your mobile applications, or even a third-party application would be able to then access and send inputs in and get predictions back. So today we'll be talking a little bit about that. I go through in this blog post here sort of what servables are, and there's a whole architecture page, some of the ways that TensorFlow serving has this concept of loaders and sources. There's various versions. It's really cool. You can serve up different versions and load them in sort of on the fly as new data comes in. So lots of really neat stuff that you're going to want to go through, and explore a little bit more on the TensorFlow serving documentation. What I talk a little bit about here now that you'll see on the screen is sort of a sequence diagram with regards to how an IoT device out in the field could then leverage TensorFlow serving to train new models and get new data. So this is a pretty simple example, but imagine there's an IoT device in the field, and these are things that we work with our customers as they're going through their journey of building devices and wanting to manage and leverage data from these devices to help, whether it be a piece of equipment out in the field with regards to managing uptime, or just generally understanding how customers are utilizing a product in the field with various sensors and data. Now we can start getting that information and running them through some really cool deep learning models, creating deep learning models. And TensorFlow serving can be a really interesting component with regards to plugging that into your existing architecture that you maybe have built. So here's an example of some data that's out in the field, sending it into a data store, and we can go ahead and train that model using the standard TensorFlow services that are already built, but now you can then feed that model off to TensorFlow serving. So now you can utilize TensorFlow serving, you have that model sort of ready to go. So now, say you have a mobile application, for example, and you want to get data by prediction of something that's going on out in the field. Well, you send a request in, and this could come through a mobile app, this could come through another IoT device, quite frankly, and you can get the prediction, get the response, and now get back sort of like the time to failure. And again, this can be any sort of information, but TensorFlow serving now can play a critical piece in the back end of your architecture and allow these requests to sort of come through. And again, this is all sort of done by REST APIs. So it's and you'll see sort of how simple it is to get this server up and running. So let's go ahead and jump into sort of how we set this up. If you haven't already installed Docker, that's the first thing you're going to want to do. The other thing that's kind of cool is TensorFlow serving then comes with a couple different models already sort of pre-built for you that you can run and test. And we'll go ahead and go through this basic model that is just, it's called half plus 2, and it just uses this equation here, this simple linear equation where, whatever value you feed into it, it takes half of it and then adds 2. So let's hop over into our terminal here, and we'll go ahead and execute the Docker pull of the TensorFlow serving image. And I've already done this, so it shouldn't really take very long at all. If it's your first time, it will go ahead and download all the components that it needs, and it'll be all ready to rock and roll. The other thing you're going to want to do is then pull the TensorFlow, use get to pull the TensorFlow serving project in. And this is all open source software. It's all available out there on GitHub. And I've already gone ahead and cloned the directory right here. So right now we're sitting here looking in the TensorFlow serving directory. We will now load in we'll set a variable called test data. And so now if you echo test data, you'll see there's a full path here down to where the test data is. And now with this command that we have here, we'll go ahead and start up TensorFlow serving and point it to our half plus 2 model. So you can dig into some of the details here, but for right now, I actually already have the project running right now. So that's why it gave me a little bit of a Docker error here, and I can show you if you just do a Docker PS, you can see I actually already have TensorFlow serving running. So if you didn't already have it running, it would go ahead and start it up and run it, and now you can just go ahead and query the model using this. And this is just using simple curl command. And if we go ahead and predict, send in some of these values here, you will go ahead and get back these predictions, which again has used deep learning to follow this this general function. So that's really cool. So now we have a REST API. We can go ahead and send instances, inputs in, and we'll go ahead and send back predictions. So let's now turn to actually utilizing the model that we built in part 1. And again, like I said, if you have not actually taken a look at the blog post in part 1, please go back and do that. This will make a lot more sense when then you are actually going to go ahead and run that model here. What I'm going to go ahead and do, this is just a Docker command here, and you can go ahead and open up another terminal if you wanted, or use the same one, but you can get a listing here of TensorFlow. There's the Docker that's running right now. We're just going to go ahead and stop that Docker container because we're going to restart it pointing at a different model, right? So let's do Docker container stop, and we'll go ahead and take this ID that we have right here. And again, if you need to read up more on Docker, certainly can. But that's what this is going to do, is basically stop our container from running. And then what we're going to end up doing over here, and I'll go ahead and clear it out, is we're going to go ahead and take the zip file that we have from our first one, which basically contained our model in it and all of the other corresponding things that TensorFlow needed to run. And that was actually done over here. And here is the end of how we built this C to F underscore model in part 1. And I'll keep sort of talking back to part 1, but here's where all the steps that we did. And at the end of the day, we ended up getting a zip file that you would have downloaded to your computer. So now when we're over here, we have this file called C to F underscore model.zip that we generated in part 1, and we just go ahead and unzip that. And you can do that with these commands right here. Now the one thing that we do need to do is to make sure that there needs to be a version number. So what we'll do right now is make sure that I'm taking a look here, and inside my serving, if I do echo again test data, where I have inside test data, I've actually unzipped it right here. So there's a C to F underscore model, and here's some of these other sample models that we have here. But if we go ahead and look inside here, the only thing you're going to want to do is once you unzip the file, you just need to make sure you put it in some sort of a versioned directory. And this number can be anything that you want. It can be 1, 2, 3, 4, 5. I just went ahead and put a bunch of zeros and 1, 2, 3. But what it needs to do is when it launches, it needs to make sure that there is some sort of a version number inside. And I talk about that. Just make sure in this part of the blog post. So I created a folder, called 00123. But if you look inside that directory, then for example, here's where your model lives and the assets and the variables. These are all things that are just standard for TensorFlow. So when you actually create a zip file and take a look inside of it after you've generated your model using TensorFlow and the Google Colab tools, these are the values that are in there. So once we've gone ahead and created that, now we can go ahead and start up our Docker image. And again, this time we're going to be pointing at our models, our C to F folder, and starting up the TensorFlow Docker. So let's go ahead and let's clear this. I'm going to go ahead and start this up right now. And now we've got it. If everything's running right, you'll get this response, building single TensorFlow model, which is basically here. And it should be running. Now you have your Docker instance that's running. It takes very, very little time. So let's go ahead and make a prediction. So let's go ahead and predict. Let's see. Again, we're going to pass in 100, and they use this idea of instances or inputs. The thing can take either of those. And this is just using, again, the curl command. We're sending in a piece of JSON saying, hey, here's 100 for a Celsius value for an input. What do you think the corresponding Fahrenheit value is? So we'll go ahead and run this right here, and we end up getting 211.27, which is darn close to 212. And if you don't know, that's already that's what 100 degrees Celsius should be equals 212. So the outputs for this are pretty much identical to what we got with the Google Colab and running it in a Jupyter Notebook. But as I said at the beginning, the beauty of this is now you have this as a standalone service. Right? You can integrate this into your entire workflow, and it can be a component of your entire architecture system. So now when requests come into your web server, for example, or they come into your infrastructure, now you can have a service that's out there running REST-based that can take a piece of JSON in and then send resulting predictions back. So really, really powerful stuff. So I highly suggest you take a look at TensorFlow Serving, start thinking about how you can integrate that in and bring this power of TensorFlow, I guess, to the next level with regards to providing a API-based solution. At the end of the day, as I said here, it actually allows you to use the separations of concerns design principle, where you have components that are handling pieces. And I see a web server doing stuff very well at serving up web pages, web interfaces, whatever it is, and then you can have it sort of powered on the back end with regards to your models through TensorFlow Serving. So really, really cool stuff. In the next one, we'll be talking a little bit more about TensorFlow Lite, which is another project that TensorFlow has. So look for that in an upcoming blog post and an upcoming video. And thanks again for your time. And please reach out if you have any questions or would like to learn more about TensorFlow Serving or about Lab 651. Thanks again. This is Justin Grammons from Lab 651. Take care.